Hi, this is Marlon Ariola and I will be discussing about the concept of basic counting principles. Now let's take a look at this problem. Coach Tim was tasked to form a team to join 2x2 basketball tournament. He was allowed to select 6 players from Barangay Ginebra, a professional basketball team in the Philippines, where he chose 3 all-star players and 3 role players. On the day of the competition, there is a sudden change of the rule. Only 5 players can be allowed to join the team, and only 1 all-star and 1 role player can play the game for each quarter. How many ways can Coach Tim can remove a player from the original 6 in the lineup? He has 6 players, 3 all-stars and 3 role players. Therefore, he can either remove a 1 or a 2 or a 3 or R1 or R2 or R3. Thus, by some rule, there are 6 ways to remove a player. In basic counting principle, or condition usually requires us to add. Assuming that he has dropped a role player in the team, how many ways can Coach Tim choose an all-star and a role player to play the game? He has now 5 players, 3 all-stars and 2 role players. 3 ways times 2 ways is equal to 6 ways. And what are those 6 ways? It is either A1 or R1, A1 or R2, A2 or R1, A2 or R2, A3 or R1, A3 or R2. 6 ways. In basic counting principle, and condition usually requires us to multiply. Now let's discuss more of the sum rule. The playing card problem. David has a deck of playing cards. In how many ways can he draw the following? A heart or a diamond. Let's do not forget the basic counting principle for or condition which usually requires us to add. Therefore, since we have 13 hearts and 13 diamonds in a deck of playing card, therefore there's 13 plus 13 ways equals 26 ways to draw a heart or ace in a deck of playing card. How about this another question, a heart or an ace? Since we have 13 hearts and 3 aces in a deck of cards, we may draw 13 plus 6 plus 3 aces is equals to 16 ways. Now let's take a look at more of the product rule for forming numbers. Suppose we will form a 3-digit number using digits 1, 2, 3, 4, 5. How many ways can we form a 3-digit number if repetition is not allowed? If repetition is not allowed, we should select first we should fill first the hundreds digits, which we in this case we have 5 ways to fill in, and then we have 4 ways for the tens place and 3 ways for ones place. Thus 5 times 4 times 3 equals 60 ways digit. Since no digit is to be repeated after a digit has been used, we choose the next digit from the remaining unselected digits. And how many ways can we form a 3-digit if repetition is allowed? If repetition is allowed, it's very easy since we have 5 digits available for each places from ones, tens, hundreds, and tens and hundreds. Therefore, 5 times 5 times 5 is equals 1, 2, 5 ways, 3-digit numbers that can be formed. How about forming 3 odd numbered digit? If 3 odd numbers digit requires and no repetition is allowed, we must first start from the ones place. We know that odd numbers start in this case from 1, 3, and 5. Thus, we have 3 choices here, and then if we already use, for example, number 5 here, we only have 4 choices here, and then this will be lessened again subtracted. Therefore, there are 3 choices. Thus, by multiplication, 4 times 3 times 3 equals 36 ways 3-digit numbers can be formed. And how many ways can we form a 3-digit number if repetition is allowed? If repetition is allowed for the hundreds place, we can fill 5 digits, and for the tens place, we can select 5 digits, and the same rule which we only have 3 odd numbers here, we can only have 3 choices. Thus Multiplying all of them 5 times 5 times 3 equals 75 ways, 3 odd digit numbers ways that can be formed. Now let's discuss about the application of basic counting principles in computer science. We are given this problem. In a computer system, each user has a password. The password must be 6 to 8 characters long. Each character is an uppercase letter or a digit. Each password must contain at least one digit. How many possible passwords are there if we will choose a 6 characters long password, 7 characters long password, and 8 characters long password? We should divide the task into 3. First is to choose a 6 character long password. The solution can be done by multiplying 36 by itself 6 times minus 26 to the power of 6. And why did we do that? Since we have 26 characters in our alphabet, and we have given 10 digits from 0 to 9, we can have 36 to the power of 6, and we need to subtract 26 to the power of 6 because 36 to the power of 6 includes passwords which contains only alphabet also. Thus we need to subtract 26 to the power of 6, and by doing that we will arrive in these numbers. For task 2, we need to choose 7 character long password. So just like in task 1, we need to multiply 36 7 times minus 26 to the power of 7 is equals to these numbers. For task 3, we need to choose an 8 character long password. Thus it can be done in 36 to the power of 8 minus 26 to the power of 8, which can derive these numbers of passwords. So by some rule, the number of possible passwords are the number of task 1 plus number of task 2 plus number of task 3. So thus we can have this. How many are these? This is 2 trillion 684 billion 483 million 63,360 passwords that can be derived from the given example. So I hope you learned something from my presentation, and that's it for now. Thank you.